Okay, well, today we are going to look at Chapter 5.6, Direct Variation. If you remember, just recently we worked with the concept of slope. This ties right into direct variation. I guess a couple words, things I want you to think about when doing this chapter would be, what does direct variation mean? Well, in words, direct variation would be two quantities, x and y, show direct variation when y equals kx. Now, what is k? K would be the same thing as slope. It's called the constant of proportionality is what the k represents, but k is the same thing as slope. So slope, constant of proportionality, they mean the same thing. So when you think of this, just think of the slope. They have more than one name. And so, again, we're looking at y equals kx. So it basically means that y equals the slope times x. So as x changes, y changes. And the change is what the slope, or what we call here, the constant of proportionality is referred as. The other part we say here is the graph of y equals kx, that's the one we talked about right up here, is a line, it's a straight line, with a slope of k, again the slope of k, that passes through the origin. That is a really important thing to understand. For it to be a direct variation, it has to go through the origin. The origin is that spot where the y-axis and the x-axis intersect. If it goes through, and it's like 0, 0, okay, so the origin is 0, 0. So it has to cross through 0, 0, and then it would form a proportional relationship. All right? So let's go ahead and move on. So in our first example, it says, tell whether x and y show direct variation and explain the reasoning. So we're given a table, and we are given our x values and our y values. And you can see our x values go up 1, 2, 3, 4. And then our y values go negative 2, 0, 2, 4. Now I think this is something interesting for you to notice. From 1 to 2, it goes up 1. From 2 to 3, it goes up 1. From 3 to 4, it goes up 1. And so going the other direction, from negative 2 to 0, it goes up 2. From 0 to 2, it goes up 2. From 2 to 4, it goes up 2. So with that, every time x goes up 1, y goes up 2. Or, also can be said, every time x goes down 1, y goes down 2. And so if I was to take this a step further, I could say that if I went from 1 to 0, I went down by 1, then y would go from negative 2 to negative 4. Now, we have to decide if this is a direct variation. So one way of doing this is we can plot the points and draw a line. And so you can see the lines that are plotted, the points that are plotted in the line that was drawn. And when you see that, you'll notice that the origin is right here. The line does not cross that origin. So the line does not pass through the origin. So x and y do not show a direct variation. I just wanted to point out that we see that 0 and negative 4 is a point. Remember, we talked about over here, it would have to be going through 0, 0, the origin. So you can look at it through the graph. Also, just through the ordered pair, you can tell. Okay? Let's look at B. I can already see right here, 0, 0. I can tell already it's going to go through the origin. We're going to go ahead and graph this anyway. So let's go ahead and graph it. When we plot the points, the line goes directly through that origin. So the line passes through the origin, so they do show a direct variation. Okay, that's example 1. I hope that made some sense to you. Example 2, identifying direct variation. Tell whether x and y show direct variation. In this case, it's in the equation, and then explain the reasoning. So what we're doing is this. Remember, we need to have our equation be y equals kx. And again, the k is that slope, right? So y equals kx, or the coefficient of x. So basically, it needs to be y equals x, and then the x can have a coefficient, okay? and it can't be anything else with it when it's all simplified. But the key is it's got to be completely simplified. And if you cannot simplify it to where y equals something times x, then it is not in direct variation. So when we have an equation like y plus 1, y plus 1 equals 2x, our goal is to get the y by itself. And then we can see if it looks like it's in that form of y equals kx. So I'm going to have to subtract 1 from both sides. And I get y equals 2x minus 1. Since I have this minus 1 over here, that does not look like this equation. So the equation cannot be written in y equals kx, that format. So x and y do not show direct variation. Now for the next one, b, we have 1/2 y is equal to x. So I'm going to go ahead and multiply 2 over 1 times 1/2 y. And I'm going to multiply x by 2 as well. So I'm multiplying both sides by 2. And the 2's cancel out, leaving me with a y. X times 2 is 2x. Look, this is the same thing as y equals kx, right? The k would be the coefficient, which is your slope, or in this case, k is constant proportionality. You got to know that word. And so this equation can be written as as y equals kx. So x and y show direct variation. So let's go ahead and move on. We now have an on your own. Now you'll notice that I've made 2 of the graph, the coordinate graphs are different than what you have. If you want to, you could do this on separate graph paper, or you could try your best on the sheet that I gave you. Or I'm going to give you one of those small sheets of paper. You can get the small sheet of graph paper from me, and I can use this to, attach to your notes. But the original quadrant I gave you doesn't really work well, especially with 3. It can be worked with 1, but it doesn't work well with 3. So you need to make that small little change. So after you've made that change, you're going to go ahead and tell whether x and y show direct variation and explain the reasoning. So go ahead and give these 3 problems a try and see how you do. All right, let's see how you guys did. I'm hoping that you used the other graph paper that we talked about. Let's go ahead and plot these points, just see how these points look when we plot them out. Hopefully, if you listen to what I told you before, like with number 1, you can already tell the answer but without doing anything. But let's go ahead and look. When x is 0, it goes 0, -2, so we're going to go right here. Our first point, our first point is right here. And then our next point is at 1, 1, which is right here. Our next point is at 2, 4, which is right here. Our next point is at 3, 7, which is right over here. Now, you should be able to draw your line better than me, but the line roughly goes like this. So the key thing I want you to notice is that it does not go through the origin. So is this a direct variation? No. It doesn't go through the origin. So the line doesn't go through the origin. Let's look at our next one. For our next problem, we have 1, 4. So we can go over 1, up 4. And then for, we have 2, 8. And then we have 3, 12. and then we have 416, which would be a little higher than this. So for this, if you're using a straight edge, it does go, whoops, oh, you get the idea. It does go through there when you're using a straight edge. I can't use a straight edge on my device here, but you get the idea. It does go through here. And by the way, the other way of looking at this, these are going up by 4 as these go up by 1. So if this is a 0 and it goes down by 1, this goes down by 4, it's a 0, 0. So, yes, the line passes through the origin. So yes, the line passes through the origin. All right, so let's go ahead and look at the last one here, number 3. For this one, we have negative 2, 4, so over 2 up 4. And then we have negative 1, 2, right here. And then we have 0, 0. And then we have 1, 2. And as you can tell with this, we don't have a line. I mean, it's starting to head down this way, but then it starts to go back up this way. This is not a line. So it would be no, the graph is not a line. No, the graph is not a line. So there's your first 3. I wonder if number 3 got you a little confused, because it looked like it was going to be a line that would pass through the origin, but it took a turn to make it a little different. So hopefully you were able to catch that. Let's go ahead and move on to our next set of problems. Okay, over here, you're given 3 equations, and you are to determine whether these 3 equations, again, show direct variation, and then explain your reasoning. So why don't you go take a few minutes to try these equations out and see how you do. And remember, you want to have your equation compared to y equals kx. So you want it to be y equals a number times x, any number times x. If it's like that, and that's, you can simplify it to that, then you know it's in direct variation. If you can't, then it's not in direct variation. So give this a try. All right, let's give this a try, see how we did. Okay, for the first problem, I have x times y equals 3. The only way I can get that y by itself is to divide both sides by x. And so now I have y equals 3 divided by x. And so this is as simplified as you can get this, because x has to be in the denominator. So this would be no, it's not a direct variation, because the equation can't be written as y equals kx. Okay? So no, this equation cannot be written as y equals kx. All right? So how about we try the next one? Here we have x equals 1/3 y. So I'm going to go ahead and reverse this because I want to have my y on the left. So I'm going to have 1/3 y equals x. And I'm going to go ahead and multiply both sides by 3, because that cancels out that 1/3, right? And it gives me y equals 3x, and there you have it. And so this would be yes, because this equation can be written as y equals kx. Okay? And then finally, we have y plus 1 equals x. Well, I'm going to subtract 1 from both sides, and I get y equals x minus 1. It's as simplified as I can get that, so no. Because the equation can't be written as y equals kx. So let's go ahead and move on to our next part here. The table shows the area y in square feet that a robotic vacuum cleans in X minutes. So we have a table to the left. We have it shows 1/2 for X, 8 is Y, 1 for X, 16 is Y, so on and so forth. So it tells us to go ahead and graph the data and then tell whether X and Y are directly proportional. So if we were to go ahead and plot these points, you can see them over here on the right-hand side with the robotic vacuum. And when we connect our dots and make a line, you can see that this line crosses through the origin, and so that tells us something. So it tells us, again, graph the data and then tell whether X and Y are directly proportional. Well, as we know from earlier, if the line goes through the origin, through that 0, 0 ordered pair, then it would be, X and Y would be directly proportional. So we can tell that based on our graph of the word problem. We can also move over here, and it says, again, the table shows the area y in square feet that a robotic vacuum cleans in X minutes. Write an equation that represents the line. So what we're going to have to do is we're going to have to figure out what the slope is. Because remember, our equation needs to be written in y equals kx, right? The y equals kx form. And in order to do this equation, we need to find out what does k represent. And again, as we learned earlier, the k represents the same thing as slope. It is the slope. It's a constant of proportionality. It's the slope, constant proportionality, the same thing. So we're going to look over at our graph. And we have a point here at the origin. And the easiest way to do this, if possible, is to have something over 1. Now, if I go just to this first point right here, I've only gone over a half of a space. So I don't want to go over there. That would not work for me. So instead, I'm going to go from this point all the way over to this point. So as you can see, I went up 16. And then I went to the right over 1. See, it goes right over to the 1. So my k is going to be 16 over 1. I guess I have it over here. K is 16 over 1, or just 16. So I can go ahead and write my equation as y equals 16x. And since I can write my equation in the y equals kx form, then I know that this is, again, in direct proportion. And so as we can see right here, my final response here would be the slope of the line is the constant proportionality, k. So the equation of the line is y equals 16x. The next, C says, this is the easy part. Once we have the equation, it says use the equation to find the area cleaned in 10 minutes. Well, let's go back to the original problem. It tells us that y is going to be square feet. That's the area. And that x represents minutes. So I'm going to change, since it tells us in 10 minutes, I'm going to do this. I'm going to have y equals 16x. I know that x represents minutes, and I know that it's going to be 10 minutes, so I can just do this. I can say y equals 16 times 10. And so y equals 160. Now again, y would be square feet, as we saw up top. So the vacuum cleans 160 square feet in the 10 minutes. All right, so moving on. Over here, hang on for 1 second. Over here, our final problem, well, actually I'm going to have a bonus problem, which you're going to need for your assignment. So our final problem before the bonus problem is saying, what if the battery weakens and the robot begins cleaning less and less area each minute? Do X and Y show direct variation? Now, I want you just to explain. I want you just to think about this question. Again, the battery weakens and the robot is cleaning less and less area each minute. Do X and Y show direct variation if this happens? Explain. I want you to take a moment and think about this, and then you just need to answer. There's really no work you have to do. You just need to answer this. So give this a try, see what you guys come up with. Okay, so let's think about this. It says the battery weakens and the robot begins cleaning less and less each minute. And it says, does X and Y show a direct variation? Well, the one thing that we know with direct variation is that it's got to be going at a constant rate. It needs to be going up the same amount. So in this case, it needs to be cleaning the same amount every minute. But if the battery is weakening and it's cleaning less and less every minute, it's not cleaning at a constant rate. So as a result, it would not show direct variation because the robot will be cleaning would not be cleaning at a constant rate. It is actually cleaning less and less each minute. So again, it is not showing a direct variation because it's not cleaning at a constant rate. Okay, the last thing I want to go over with you guys, this is kind of important. Let me give you a little bonus problem. I'm going to pop this up here real quick. Okay, so you're going to want to write this down. The variables x and y vary directly. Use the values to find the constant of proportionality k. Then write an equation that relates x and y. So our values would be x equals 12 and y equals 3. And so we want to find out what our k is. Well, I want you guys to think about this. This is where you have to start thinking algebraically. The one thing we have learned is we've learned this equation. Y equals kx. I want you to think about what we know and what we want to find out. What do we know? We know that x equals 12. X. We know that y equals 3. Y. And we want to find out what k is. So do we have enough information to find this? What do we have to do? Well, what we need to do is we're going to plug in the information we know, just like any other equation. Plug in what we know, solve for what we don't know. We know what y is. Y equals 3, right? We know that y equals 3. And we know what x is. X equals 12. We do not know what k is, so k just remains k. We're going to multiply here. So if we have k times 12 equals 3, we want to get k by itself. So how do we do that? we're going to have to undo the operation of multiplication through division. Divide this by 12, and divide this by 12. And we're going to simplify it, which would end up giving us 1/4. So 1/4 equals k. So right now we've found out what the constant of proportionality k is. Now we just need to write the equation. That's the easy part, is writing the equation. Now we know it's y equals 1/4 x. And that is our equation. I know you have a few problems like this on your assignment, so I want to make sure you guys had an example. So make sure you write this down in your notes so you can refer back to it during your assignment. Okay, best of luck. Have a great day, and we'll talk to you later.